Right, good afternoon, everyone. Hopefully you can all hear me. My name is Philip Briscoe from Resitech. Thank you for joining us for today's webinar. We will want to give you a quick overview on how we're applying Earth observation data, so satellite data, to support catchment management initiatives. So I'll start by just briefly introducing us as a company, and then I'm joined by Matt Pitts, who's the Catchment Strategy Manager for Bristol Water, one of the organisations working with us today. And we'll talk a little bit about how Matt is using the Earth observation data analytics in the context of his work. And then we'll show you a short demonstration, my colleague Alistair, of Matt's Bristol Water's portal, so should bring it to life a little bit. And then at the end, there's time for any questions that you may have. If I could ask you please just to mute your phones during the main section, and then when we get to the Q&A, feel free to unmute yourself and ask away. I don't suspect we'll go longer than 25 minutes, half an hour, so we'll nice and manageable. So first off, just let me introduce Rezatec. So we're based in a place called Harwell in Oxfordshire, which is becoming the kind of UK's space centre, certainly for commercial applications of satellite data. And we are focused on what we call providing landscape intelligence. So essentially we're using the vast amount of satellite and other sort of Earth observation data that's available. We are taking all of that, we're processing it, we're applying our analytics to it in order to derive business tools, really. So we're trying to take all of this space data and make it accessible and valuable for businesses. You can see there we work in a number of different sectors, really any sort of sector that manages land or manages assets from land, so food and forestry are good examples. But water is probably where we have most traction, and you can see a few companies there that we're working with. We're starting to work in Australia now as well. Just a quick note on our approach, and hopefully you'll get an idea of this through the session today. But essentially, we don't own any data ourselves. We require the right data, so it could be satellite data, so it could be optical data, it could be radar data, it could be aerial data, or it could be ground-based observations. So we take the necessary data, and then we take it through a series of analytical steps. So first off, we might take a multitude of different data sets in order to derive an analysis of soil, for example. As a component, we might look at different plant communities, different vegetation types that may give us an indication of the land use and perhaps the health of the land. And then we'll look at things like, for example, anthropogenic features with man-made activity on the landscape. And then we'll take those kind of component layers, roll them up into something which is a kind of useful tool for catchment management or other sorts of business uses. So things like pipeline leakage detection, crop mapping, and be able to look at the risk of agricultural-based diffuse pollution based on the landscapes, and that's something we'll look at today as well as things like environmental habitats, connectivity mapping. Again, we'll look at that today in a bit more detail. So that gives you a bit of an overview on how sort of approach that we take. Everything's visual. You'll see it in the demonstration. It's kind of hosted kind of mapping type interface. If you're familiar with GIS systems, then you'll be familiar with the type of approach that we take. So today, just looking at catchment management, the questions up there, I'm sure between you probably these are probably relevant to the vast majority of you in your day-to-day jobs. So what we're going to do is really give you an idea as to where our sort of approaches can help answer some of those questions. Not all of them, but some of them will be complementary and supplementary to your existing programs. But it's really to take advantage of having a lot of high frequency updated scalable data that perhaps gives you an insight into land use and its impact on water quality that you may not have for more traditional means, maybe kind of land-based observations. So we're joined by Matt Pitts today, Catchment Strategy Manager at Bristol. We've been working with Bristol Water for about a year or so now. We did a kind of proof of concept project with them in a couple of the catchments, and we did a kind of agricultural intensification analysis looking at the change in land use and predominantly agricultural land use over the last 40 years, which is quite an undertaking. And then we looked at kind of derived diffuse pollution, so phosphate, nitrate, etc., outputs as a result of that at a catchment level. And since then, we've then taken the project further and we've increased the scope. So we're looking at about 8 catchments now across Bristol Water's area of interest. And there we're looking again at the crop mapping, and we're starting to also look at environmental habitat mapping and connectivity analysis, which Matt will talk about, and we'll show you in a bit more detail. So Matt, welcome, and perhaps you could just start by perhaps just giving an introduction to your role at Bristol and the sort of programs that you're focused on.
Sure, thanks, Philip. I manage the catchment management program we have going at Bristol Water, and I manage the water quality and water resources elements of our NEP as well as the catchment management. We have an NEP, which is a National Environment Programme, which is handed down to us by the Environment Agency. It's basically a group of environmental investigations that we need to undertake over the AMP period. Our catchment management programme focuses on the catchments for our Mendip reservoirs, so that's Chew Valley and Blagden Reservoir. They're primarily surface water runoff, but there's some sort of limestone geology on the higher Mendip areas. We started this catchment management program in the Mendips in AMP6, so last year, but we've also had a longer running program north of Bristol on the Gloucestershire, Cam and Froome catchments, and that is primarily concerned with metaldehyde, whereas the programs that we're running on the Mendips are based around nutrients. That's a summary, I guess, where we are.
And Matt, what was your kind of initial interest in looking to test, Earth observation, as a kind of means to supplement or support some of your initiatives?
Well, for me, the first job really around the catchment management project really was to assess risks and where the risks are, and to do that we've used a number of approaches, one of which has been to actually try and get out there and walk over the catchments and understand them from direct observation. We're quite fortunate in a way because we've got quite manageable catchments in that respect. We can actually walk across them over a period of days or whatever. So using the Earth observation data was a sort of supplementary approach to that, to try and understand what the land use is, what the sort of vegetative cover is, what the land use intensity is. So we also saw that the tool could be a really good aid to kind of engaging farmers, the people that we have to talk to try and work out in the catchments. It forms a really good visual point of interest for them, I think. And I'm certainly aware that the agricultural industry is starting to look at this sort of approach for its own objectives really as well.
I got through on the audio.
And so thanks, Matt. So in terms of how the sorts of applications that we've kind of worked with you on, there are different areas here. So we've kind of looked at first of all agricultural, crop mapping, land use mapping. So you talked a bit about your interest there. I mean, how do you see, how is that adding value to what you're doing, and how are you going to look at it, as a tool moving forward?
One of the most useful things, as far as I'm concerned, is that up to date, and we've had land use mapping before, and that's been used in catchment management, numerous applications, but it's based around sort of census data from. It's always a few years old. It's always a bit out of date. So having a resource which we can obviously take a snapshot from, say, June last year, but we can actually look at how the land use has changed within a year. That's quite interesting in terms of understanding how the risks change within a year. For instance, when you're going to have bare soil when maize is harvested, that's not going to be the same risk when that crop's in. So that's a powerful tool, I think. You mentioned before that we looked at land use intensity, hindcasting using satellite data from the 70s, and that was a really powerful, interesting approach and that's been interesting for farmers that we've been able to show in the catchment how land use has changed over the years.
And then looking at things like soil erosion risk, which was an area you were interested in us looking at. How have you found the outputs there in terms of using them in your day-to-day operations?
Yeah, I mean that was one of the first things we wanted to do, was to explore sort of field scale soil erosion risk, and we've done that based on the sort of universal soil loss equation, which is a fairly well accepted approach, I think. Again, we've been able to take that out to farmers and show them on a sort of field scale that this is where we think there's a problem, this is why we think there is, and it actually leads to us being able to go out in the field and have a look. And sometimes we can ground truth that problem and say, yeah, that's kind of what the model's telling us, and sometimes it isn't, but it kind of forms a starting point for conversation, which is really useful for me.
And more recently, we've been looking at your interest in kind of environmental habitat monitoring and connectivity. Could you just give a bit of a background to the requirement there and how we kind of co-developed that?
Yeah, there's a bit of a sort of supplementary side to the catchment programs that we're running. We want to not just, obviously the main interest we've got is on water quality and controlling nutrient loss from the land, but we're also looking to, wherever possible, get sort of wider benefits where we can, particularly around habitat restoration. So we wanted to understand where in the catchment might we be able to restore or recreate habitats to best effect. So we work with you guys to understand habitat fragmentation, understand where, in terms of sort of species effort, where it might be most worthwhile to focus efforts around restoration. And we can talk to farmers in the catchment about their mid-tier and higher-tier stewardship applications and say, look, this is something that you can sort of mention as a supplementary point to your application, that we've identified that this might be a hotspot, if you like, for a really good opportunity. I think we focused on woodland habitat to date, but we're looking to widen that out a bit to grassland as well, because that's a key habitat in our catchments. Okay,
thanks. What sort of, compared to perhaps more traditional methods that you were using previously, what benefits have you seen of incorporating this perhaps more scalable kind of approach to looking at land use and what's going on within your catchments?
Yeah, I think, as I said before, it's probably around the fact that it's up to date. It's impressive, I think, for the people looking at it from outside the company and that we're trying to engage with. And I think, we've explored different concepts, for example, around the habitat. It's quite flexible and it's a developing field, so it's quite exciting to think, there's going to be possibilities that we haven't even really dreamt of, maybe, to work with this data in the future. So, it's developing all the time and it's flexible. As you know, we've met with the Environment Agency and Natural England, who are the NEP kind of regulatory bodies for us, to try and explain what we're doing to them, and they've been pretty on board with what we're doing as well, so it's good from that respect.
Okay, thanks. And then finally, Matt, I mean, how do you envisage this, being used in the future or extending capabilities? I mean, even outside of what we're doing, I mean, what do you see the kind of the real benefits and future of this sort of approach?
Well, I've mentioned it as an engagement tool, and I think that's really good. I think if we were working across larger areas, its obvious benefit is as a tool to focused effort where there's most risk. It's a risk identification tool. I think for us, because we found that we're working across fairly manageable small catchments, we can kind of understand what's going on from getting to know the people out there and getting to know what they're doing and that sort of thing. But for companies with bigger areas to deal with, I can see it'll be a real benefit.
Okay, thank you, Matt. What we'll do is we'll show you the portal that we've generated for Bristol Water, which should hopefully bring some of what we've just said to life a bit. So Alistair Cunningham, my colleague, and who's actually been pretty instrumental in developing a lot of this with his EO expertise, who's going to give you a quick demo now just to show you how this all fits together. Alistair, over to you.
Good afternoon, everyone. So I'm just going to talk, give you an introduction into the sort of products that we've developed for Bristol Water, but also more generically the products that we produce in the catchment management field. So the initial one, as Phil mentioned, was understanding the agricultural landscape and the land use, but more specifically to that, understanding the changing crops. As Matt mentioned, we provide a very up-to-date service, and we try to map on a biannual basis the changing land cover and the crops within the landscape. So if I just load up on the portal, I'm just going to load up June 2015, the most recent summer crop classification that we've done. And in here you can see, if I just add on field boundaries. So we've taken these field boundaries from the OS master map layer, and using a combination of both multispectral imagery and radar imagery, we've combined these two data sets into a machine learning algorithm. We've trained that algorithm and we've used it to classify. Specifically, you've got 7 to 8 land covers here, but these are just regional to Bristol. There are additional crops that we can map, such as sugar beet. And we do this across the catchment, and specifically, as you can see within the field boundary scale, we identify the main crop within that field boundary. And we've done this historically, as Matt mentioned, as part of that hindsight analysis. And we've also done it, as you can see, for both December and June. So you get the understanding of how the land is changing, how the individual fields are changing. And in relation to that, we start to understand what contribution this land cover can have to the inputs into the water network, so your nitrates and your phosphates. And we are using a lookup table from regionally derived statistics for application rates for farmers for these specific crops. We calculate the total on a field basis, and then we can start to understand how that contribution is playing to the wider catchment. I can give you an example. We can do this at various scales because we've mapped all of the catchments, but just to give you an idea, I take these 2 layers off. We can start to look at catchment totals and understand what the total contribution could be in kilograms in terms of the total applied within that landscape for both nitrates and phosphates. And just gives an understanding on a per catchment basis what the cumulative total is across that period. We can do this at higher resolution, so this could be at sub-catchment scale, based on the fact that we're actually calculating this per field. So now there's a spatial understanding of where the different contributions are, and as part of more nuanced analysis that we do, we start to look at things like rainfall runoff rates and the actual uptake from the different crops to understand how, rather than just the direct application onto those fields, how ultimately that leads to what is eventually comes into the lakes, as you can see here, the Chew Valley Lake and Blagden Lake as an example, but ultimately what goes from being directly applied and then finally feeds into the watercourse. In addition to that, so that's understanding the sort of nutrient applications. We also look at the organic matter, so we look at the temporal soil erosion risk, which is another one of our products that we've derived. Let's take the field boundaries layer off a second. So this is spatial understanding, as Matt mentioned, when the land cover changes and you end up with exposed soil. Based on both that, the changing land cover, and the topographic influence, we start to understand how potentially these sources of risk in terms of exposed soil can enter the water network, and this is done on a more regular basis. We do this whenever an optical image becomes available and we're able to characterize the percentage of bare soil to vegetated surfaces or covered surfaces. And with that in combination with the topographic slope, we can see potentially where there are sources of risk of organic material entering into the water network. And again, that's another engagement tool, as Matt mentioned, for speaking with farmers. And then finally, going on to the third product that has been discussed, and that's the habitat connectivity. We primarily wanted to understand what connectivity was currently in place, and then if I show you just a map of this is so this is looking at your core habitats. In this instance, the model is derived on woodland-based species, but as we also have the grassland option. This is just an example of the woodland case study. And this just shows you, using the scale on the left, understanding what, with the existing framework of things like hedgerows, linear pathways such as buffer strips, beetle banks, understanding how well that network is integrated and where potentially there are gaps. And in terms of that, if that's the integrity effectively of the different linear pathways, you can understand then, based on that, mathematically you can calculate what effort is involved for woodland species to navigate across this example landscape from one area to another. And you can see between the combination between those two layers that there are areas where there is some existing connectivity, but actually the effort involved to connect up core habitats is somewhat fragmented. And in order to understand how best there is an opportunity to sort of act upon or manage some of these features, we created a habitat connectivity opportunities layer. I'm just going to change the base map for this one because it does help to have the context of the land cover for this one. And in terms of understanding this, you can see that there's three options from which to base management decisions on. And these use the priority habitat indexes, which index habitats, which are yellow, which are your preserved landscapes. And the blue would be gaps in the existing network. So these are somewhere that the land management team may want to focus efforts and potentially trying to bridge some of those connectivity gaps that have been obtained through our product. As I mentioned, this is a temporal product, so this is updated. This is not just a static map that remains constant for 5-10 years. The idea is, with the increased continuity of satellite imagery that passes over frequently, you would be able to update this map, and therefore, if there was changes in either decreased connectivity or improved connectivity, this map would be dynamic and would change with time also. That's all from me. I'll pass you back to Phil.
Thank you, Alistair. This has been very brief today, probably deliberately so. We don't want to take up too much time. It's really to give you an idea of the sorts of applications that we're able to apply to support catchment management. Generally, this isn't the extent of what can be done. There are other areas. There are probably areas we haven't even looked at yet. So please feel free to contact us if you want to talk about anything in more detail, if you've got any ideas, or perhaps just want to drill down more on anything you've heard today. And we will send a kind of follow-up email anyway off the back of this, and also there'll be a recording if you want to share it with any of your colleagues. But if there's nothing else, then I'd just like to thank all of you for joining me and Matt and Alistair today. And Matt, just to thank you for your time as well.